What if I told you that the future of fuel for our biggest, heaviest ships and trucks isn't in some high-tech lab? What if I told you it's in your garbage can? Yeah, today we're diving into a fuel that could completely change the game for heavy transport, and its source is something we all throw away every single day. I mean, just think about the scale of that question for a second. We're not talking about a car here. We're talking about a floating city, a monster cargo ship that literally moves our global economy. How in the world do you make something that huge go green? And look, let's be real. The answer isn't as simple as just plugging it in. For the absolute giants of our world, those long-haul trucks, those massive container ships, the weight, the range, and the charging time of batteries, well, they just aren't practical. We need something else, something dense, powerful, and clean.
So, if batteries are out, then what's in? Well, the answer comes from a place we usually try to get rid of as fast as possible: our waste. Seriously, we're talking about a fuel made from garbage, manure, and agricultural scraps.
It's called Bio-LNG, or liquefied biomethane. And here's the most important thing you need to know. On a chemical level, it's a perfect twin to the fossil fuel LNG. But where it comes from, its whole origin story, and its effect on our planet, they are worlds apart.
And this is the fundamental difference, right here. Fossil LNG takes ancient carbon that's been locked away underground for millions of years and just pumps it into our atmosphere. Bio-LNG, on the other hand, is completely different. It recycles carbon that's already a part of our world. From plants, from waste, it's a circular system. And because it's that chemical twin I mentioned, it's a 100% drop-in replacement. No new engines, no new infrastructure. You can literally use it tomorrow.
So how do you actually turn smelly farm waste into a high-tech fuel capable of powering a ship? It's a pretty fascinating four-step transformation. Okay, so it all starts with bacteria in a big oxygen-free tank. Think of it like a giant mechanical stomach. These little guys get to work breaking down the organic waste, and, well, they produce biogas. Then, that raw gas gets purified or upgraded into almost pure biomethane. But step 3, liquefaction, is where the real magic happens. The gas gets super chilled to a mind-boggling negative 162 degrees Celsius.
And the result of that extreme cold is just incredible. The volume of the gas shrinks by 600 times. Let that sink in. 600 times smaller. That massive reduction is the entire key. It's what makes Bio-LNG so incredibly energy-dense and easy to transport. It means you can pack a tremendous amount of power into a relatively small tank, which is exactly what a giant ship or long-haul truck needs.
So, we've talked about it being carbon neutral, which is already fantastic, but Bio-LNG has this surprising superpower that goes even further. With certain feedstocks, it's not just neutral, it's actually carbon negative. Now, I know what you're thinking. That sounds completely impossible, right? How can burning a fuel actually result in a net removal of greenhouse gases from the atmosphere? That sounds like cheating. Well, take a look at this. This is the hero number. It's the carbon intensity score of the fuel, basically how much greenhouse gas is emitted for every unit of energy it produces. For some context, gasoline is way up there, around positive 90. Bio-LNG made from dairy manure can be as low as negative 141. No, that is not a typo. It is actively removing pollution potential from the atmosphere before a single drop is even burned. So, how on earth is this possible? It all comes down to the source. Dairy manure, when you leave it sitting in those big open lagoons, naturally releases methane. And methane is a super potent greenhouse gas, over 80 times worse than CO2. By capturing that methane and turning it into fuel, we're not just creating energy, we are preventing a climate superpollutant from ever hitting the atmosphere in the first place. That's the secret. And the benefits don't even stop with carbon. Compared to the dirty diesel that powers most trucks and ships today, Bio-LNG is a huge step up. It produces virtually zero sulfur oxides, and it slashes nitrogen oxides and particulates, the nasty stuff that causes smog and hurts our lungs, by up to 90%. That is a massive win for air quality in our ports and cities. All right, so we have a fuel that cleans the air and can even help reverse climate damage. This all sounds amazing, maybe even too good to be true. But can it actually scale? Let's take a look at the economics and what the road ahead looks like. Okay, so right now it is more expensive than fossil LNG, and this chart pretty much shows you why. A whopping 70% of the cost comes from the really complex process of collecting all that waste and actually producing the biomethane. But, and this is a big but, as this technology scales up and gets more efficient, those costs are projected to come down a lot.
And when we say scale up, we really mean it. The market is projected to absolutely explode, from about $1.4 billion just last year to over $32 billion by 2032. That's a staggering 41% growth rate every single year. The demand is definitely there.
And this growth is happening all over the world. Europe is kind of the current leader here, but the US is catching up really fast, and huge players like China and India are just starting to tap into their massive waste resources. You've got major energy companies like Shell and Total Energies investing billions. That tells you this is no longer some niche experimental tech.
It's really important to see Bio-LNG in its proper context, though. For a long time, it was just an idea, but now in the 2020s, it's becoming this critical bridge fuel. Now, is it the final, permanent answer? Probably not, but it's the perfect technology to get us off fossil fuels right now using the infrastructure we already have while we work on perfecting the next generation of fuels like green hydrogen and ammonia. I love this quote because it just gets to the heart of it all. This is a truly circular economy in action, where the problem, our trash, literally becomes the solution that powers the entire system. It's just an elegant, efficient, and incredibly powerful idea.
So Bio-LNG is here. It's real, it's scaling, and it's buying us some absolutely crucial time in the fight against climate change. It's cleaning our air and solving our waste problem all at the same time. But remember, it's a bridge, not the final destination. And that leaves all of us with a pretty critical question. What kind of sustainable future are we going to build on the other side?